皆さんこんにちは。僕はミスタースーです。今日のビデオはパラメトリックの関数です。一緒に始めましょうよ。Alright, so let's talk about parametric equations. First thing is we need to figure out what they even are. So before we go into parametric rectangular, so what are they? They are equations, so that little thing means equations. So they're equations where x and y depend on each other. So when you have the xy coordinate plane, you usually have something like x comma y, those coordinates. Usually we say that y depends on x, or y varies with x, or something along those lines. Or you can define them the opposite. So for example, if we had something like y equals x squared, and x equals square root of y, essentially we see that in the first one, y depends on x in the sense that if you square x, you get y. In the second one, we see that x depends on y. So same type of thing, but just switched around. Now for parametric, that changes. This is where x and y actually don't depend on each other at all. So you can have xy coordinates where they have nothing to do with each other, but they depend instead on another parameter or variable. So parameter and variable, they essentially mean the same thing. You can kind of think of them as the same thing for now. But anyway, yeah, so they don't depend on each other, they depend on something different. So we can look at an example. So I'm going to give you two equations, an x of t and a y of t. That's how they're normally written. So x of t will be, let's see, 2t plus 1. And then this will be t cubed. Yeah. So as we see here, there's another variable, this t. So x and y depend not on each other, but rather they depend on this parameter called t. So as t varies, so will x and y, and that's how we'll get our coordinates using each of those t's. So the question is, how are we going to even start this then? Well, you can choose different things, but for right now, let's just quickly look at another example of a parameter type thing. Notice here, I don't have t. I have something called theta. So here we have x of theta equals 2 cosine theta minus 1, and we have y of theta equals sine of 2 theta. Here it's different, but also kind of the same. Same concept, different equations obviously. Here this variable or parameter is theta. So as theta varies, so do x and y. Alright. So just keep that in mind, you have another variable. You don't use x and y with each other, but you're able to get the coordinates, so they are important. And basically, once you find the values of these, you're able to start to plot a group of coordinates, and that's how you get your graph. So let's just try an example of that real fast. Let's look at this one. X of t equals 2t minus 1, y of t equals t squared plus 2, and I have a little xy coordinate plane here. So what we'll do is we're just going to plot a t-chart. That'll be the easiest way to see what the coordinates are. So let's see, where should we start with t? Let's do -2, -1, 0, 1, 2, and 3. So you're probably familiar with using x and y to make these sorts of t-charts. But in this case, again, because x and y don't relate to each other directly, we're going to use t. So starting over here, when t equals -2, we can plug that in. Or actually, let's start with 0. Because 0 is easier. And then we can see that this is a slope of 2. So each way we go, and it's a line, it's going to be plus or minus 2. So starting at 0, we can just go negatives, go positives, skipping 2 each. So we're getting the odds. All right, for y, same idea. So we plug in the t's into the t's, and we get our y values right there. Before we do that, I'm just going to kind of get some of the points on the x-axis and the y-axis so that we have an idea of what we're going to do and how we're going to plot it. All right, just going to go to 4 each way, and then 5 will be the ends over there. And notice the way that I'm plotting these. This is just a good way to label your graph. You only need to label the first and the last part. Anyway, going on. Y column. We've plugged in 2, and then we can just do the rest of them real quickly, plugging in those values in there. You got 3 and 3, and then 2 squared is 4. Add 2, you get 6. And last one, 3 squared is 9. If you add 2 to that, you will get 11. All right, so now we have our xy coordinates. Now we are able to just plot that onto our graph. So looking at the points that we have, we'll kind of arrange the y-axis so that we can fit all these points, or basically fit them. So let's just divide that. So notice that I initially plotted stuff, but then I changed it a little bit so that we can make up for everything that we need. That's okay. And figuring out how your axis is going to look and how many tick marks is what number and whatnot, that just takes practice. Just keep doing it, and then you'll start to notice, oh, this is a good idea, this is a bad idea, blah, 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 blah. Okay, now we got this. Let's plot. So I'm just starting at the 0 point. It doesn't really matter where you start, because you're just going to be plotting a bunch of points, right? So we got -1, 2, and then the next one we have is 1, 3, 3, 6, and then 5, 11. That'll be like there-ish. And then going the other way, it's kind of symmetrical, actually. Sometimes they will be, sometimes they won't be. But basically just look at the points, the xy coordinates, just plot them in. And then once you have that, obviously what you're going to do is connect them together, right? That's just what you do with a normal graph. So connect them as well as you can. Sometimes they'll look a little bit weird. And here, I'm going to draw some arrows. These arrows indicate what direction the parametric equation is going. And direction, there's a special word that we use for parametric equations in particular. That word is orientation. So if you have ever heard the term orientation in any context, it always has to do with direction of some sort. All right, so rectilinear or rectangular form to parametric. So you're just going to use logic to write the parametric equation, as an x or y function. So we're going to make them dependent on each other. Here, we can take x equals 2t, and then we can isolate for t. So we get t equals x over 2. That's simple, right? And then for y, we can just plug that t directly in to there, because, I mean, they're the same thing, right? So it makes sense that you're able to just plug them in. So That means y equals that thing squared. What is that thing? It is x over 2. When you do that, you end up with x squared divided by 2 squared, or 4. And we've written that in rectangular form, or rectilinear form, whichever one you want to call it. They mean the exact same thing. All right, let's try this one. So we can basically apply the same concept. X equals cosine of t. How do we get t alone? We apply cosine inverse to both sides. And remember, that's cosine inverse of x, not times. All right. Well, now we have t, and we can plug that, again, directly in for the other t. So we get y equals tangent of 2 times that thing. And that thing is cosine inverse of x, because that's what t is. And all you're doing is multiplying by t. Okay, so not too difficult. All you're doing is isolating and plugging in. So now let's try to reverse it actually and get y of x. Because you can do that, right? So y equals tangent of 2t, as we see up there. And then we can isolate for t first by tangent inversing both sides. And then now we have to divide that 2 out. So t equals tangent inverse of y divided by 2, or a half tangent inverse. They mean the same thing, right? Okay, so now this is our t. And what are we plugging it into? Y. It only makes sense to do, x, sorry, not y. That's the only thing that makes sense. So we have x equals cosine of, just directly plug that t in. We get cosine of 1/2 times tangent inverse of y. And that's it. So we box that. That's our answer. Now we're good. ご覧いただきありがとうございました。このビデオを楽しめたといいねしてコメントして購読してください。次のビデオに会いましょうよ。